Hello class, today I come to you from the iPad courtesy of Black River Public School, and we're going to take a look today at a function that describes the height of a squirrel for any given time t, and we're going to consider time to be in seconds. So the first thing I'd like to do is take a look at the graph. From what we can see right now is that this graph shows the height of the squirrel as we climb t in seconds. And it appears that the squirrel starts on the ground at 0, 0. As time progresses, seconds progress from 0 seconds up to 1 second, we see that the squirrel is climbing the tree up to 6 feet. Then from 1 to 2 seconds, the squirrel is coming back down the tree, falling down from 6 feet to 3 feet. And then from 2 seconds up to about 2.5 seconds, we see that the squirrel stays around 3 feet and then climbs back up again between a time of 3 seconds to about 3.5 to 4 seconds, back up to 6 feet, and back down again, and then back up to a height of only 4 feet, and then finally is coming back down the tree, ending at 1 foot off the ground at 7 seconds into its path. So that's how we describe the motion of the squirrel. But now let's take a look at some notation issues. You should see here in 2a that we're trying to find the height of h of 3. What that is referring to is the height of the squirrel at a time of 3 seconds. So let's take a look at when that occurs. Right here we have 3 seconds. And if we look at the height of the squirrel at 3 seconds, if we trace 3 seconds up to where the height is, that appears to be taking place at a height of about 5 feet. So to answer this question, h of 3, we're finding the height at 3 seconds, and we find that to be about 5 feet. Okay? Next, we're taking a look at the height function as it equals 5 feet. This is now telling us, or asking us to find, at what time we are at 5 feet, the squirrel being at 5 feet above the ground. Alright, so let's try to find that. First thing I like to do in a problem like this is actually mark on the graph where 5 feet is. So in green, I'm going to mark out where 5 feet off the ground is. That would be all along this line right here. That's 5 feet above the ground. We're equal to 5 feet at several different points. At this x value, again here at this x value, again here at this x value time-wise, and one more time right here at this x value. Each of those appear to occur at intervals between full seconds. So we're at 5 feet at 0.5 seconds, or again at 5 feet at about 1.5 seconds, again at 3 seconds, and lastly at 4.5 seconds. This question is different than part A because this one is asking us to find the times for which the height is 5. So we're trying to find the independent values, the x values, the inputs, when we're given an output. Solving this kind of equation has us find the inputs, find the t values, find the x's. In the first one, in part A, we had to find the y, the output, given a certain input, the x value, or in this case, time. What's the difference? Okay, let's move on. Part 3 of this question then asks about an inequality. Finding the solutions to where h of t is greater than or equal to 5. We're going to find this in words, in symbols, and put our answer in a number line. And we're going to also talk about the context of what this means. So first of all, you see that h of t being greater than or equal to 5. Well, in part 2 of this question, we found where we're equal to 5. And we found that that was at the several different intervals. It was at 0.5, it was at 1.5, it was at 3, and at time of 4.5. Those were all of our time intervals for our time positions where we're exactly at 5. This inequality now is asking us where our height is greater than or equivalent to 5. So on our graph, we see that everything above the line, all the values up here, are above 5 feet. So we're looking at time intervals that are between our two, where they were equal to. So between this value of 0.5 and 1.5, the squirrel is above the 5 foot mark. Between 3 and 4.5, we're above the 5 foot mark. So to write out our solution, we'll include this in our words, and if you listen to my words a little closely here, we mentioned that the times between 0.5 seconds and 1.5 seconds, the squirrel is above, height above 5 feet. and also between 3 seconds and 4.5 seconds. In symbols, we would write this using the inequality symbol. Okay, so we're in between values, but we're also going to include when we're exactly at 5 feet. So we will write our first interval as 0.5 is less than or equal to the time, which is less than or equal to 1.5 seconds. That's the first interval in which we are greater than or equivalent to 5 feet above the ground. The second interval occurs when we start at 3, and 3 will be less than or equal to the time, which will be less than or equal to 4.5 seconds. So these intervals show in symbols where the squirrel is at a height above 5 feet or equivalent to 5 feet. Excellent. Now let's take a look at how these answers show up on a number line. Well, we're going to read the number line from left to right. So we're first going to indicate where 0.5 is on our number line. I'm going to go back to red here in this color. So 0.5 shows up right about here. Okay? Now, I first have to think, is this going to be an open circle or a closed circle? And the line underneath the inequality sign, right there, that indicates that we're going to have to use a closed circle. We are including 0.5 as part of our solution set. So we'll put a closed circle at 0.5. I'll put a second closed circle at 1.5. And then the idea is to shade in between them. Okay, that's one interval that shows our solution. The second interval is between 3 and 4.5. So I put a closed circle at 3, a closed circle at 4.5, and I will shade between these two as well. Right, there's our number line solution. And lastly, let's remember what this context means. This means that the squirrel is above a height of 5 feet between 0.5 and 1.5 seconds, as well as between 3 to 4.5 seconds. Okay, thanks for tuning in.